Welcome to another video on smart architectural programming, and in today's video we're going to again go over another blind 75 list of LeetCode problems. These are the top 75 questions that most commonly appear in coding interviews, and we're trying to solve all of these to help you basically if you get any value from these from our videos on our channel, please like and subscribe. And if you have any questions, any problems that you want us to address in another video, please let us know in the comments below. So with that, let's focus on the problem at hand. Today's problem is the kth largest element in a stream problem. It's related to heaps, heaps related problems in the blind 75 list of questions. So what is the issue? What do we need to do in this problem? So presumably you're given a list of numbers. Let's open the whiteboard and solve this question there. Give me a few minutes. So basically, generally speaking, given a list of questions, what we need to do is we need to find the third largest element in that problem, right? It seems simple enough, but we also need to find the best and the most optimized solution to solve that particular problem. And that solution is something that we need to work towards, right? So let's start with the most simplest of our solutions and then work our way from that. So given, let's use the blue color. So let's say given we have numbers 2, 7, 5, and let's say 9, right? So these are the numbers that we have. So this is an unsorted list, right? Potentially, if you are, if you're someone who holds even a little bit of experience in programming, you say that you might be thinking the best way would be for us to just simply convert this into a sorted list, right? Let me just get this arrow colored in properly. So given that, we can have another list here which is sorted properly. So 2 is the smallest number, then 5, then 7, and then 9. So given that it's sorted, it would take us to find the third largest number, largest number, which is 5, right? It would take us log n of a time to find this problem, right? So that is the time frame for this question, which is more efficient than if we searched for the third largest element, which is again 5 here in this problem, which would have been O of n, right? So given that, this is a better problem. But there's an even more optimized way to solve this problem. And the best way to use is what we call heaps. And we're going to use the minimum heap. So what is the minimum heap? It is a sort of data structure that you can use where if you have a list of values, you basically are able to efficiently solve this problem. And it's very, very efficient, right? So given that we have the same values 2, 7, 5, 9, right? We have 2, 7, 5, and 9. So given that we have these values here, right, we again can simply solve this problem. And we're given the value k, right? So as a context, k is the value given to us, right? So when we say third smallest problem, that was just me presuming that the value of k is 3, right? So if the value of k is not 3, it's 4, it's 1, it changes at the same time. So k equals to 3 means the third largest value. If it was 2, it would mean the second largest value. It was 1, the largest value, right? So that is how k works. And this is a minimum heap, right? It's a min heap that we're going to be using here. So why not a max heap? Why we're using a min heap? You'll understand the significance of that, right? So in a heap, we can easily remove a value of that heap very, very quickly. And what we're going to do in given a heap and given a value of k. So if we have k equals to 3, we're going to just pop off the value at the end, the value value basically the smallest value, right, the minimum value, and that's where the min heap comes in, and 2 is the minimum value, so we pop that off. Let me use a red color to do that. So we pop the red value off, right? But at the same time, this might not have been an efficient solution, given that we just need to remove values based on our value of k. But that is not the issue. The issue is we might need to add values in our input. We might be told we can add 7, or we might need to add 11 here. So we might, 11 might have been added to this in the heap, right? Then we need to remove again the smallest value until the total values in the heap are only 3, which would mean, so we will also cut out 5 here, right? So we still need to find the third largest value here, right? So which would mean that the smallest value, which is 7 here, is our third largest value. So that is how a min heap would solve this particular problem, and that's how we need to solve this problem as well. So given that, let's move on to our code base. As you can see, we need to first initialize a min heap using a heap queue, which provides efficient heap operations, and then we add all of the numbers in the initial stream to the heap, keep its size under or equal to the value of k by removing the smallest elements in every iteration. So that's our initial class that we defined right here, and what it does as we stated just now. After that, what we need to focus on next is basically this particular explanation was for this particular section where we used heap queue to sort this particular method out. Then the second thing we need to do is that add an element. So if the heap size is less than k, we add a new element to the heap. Otherwise, compare the new element with the smallest element in the heap. If the new element is larger, replace the smallest element with the new one, and return the smallest element in the heap, which represents the kth element. Generally speaking, this is initializing the heap would take the time of O n log k, where n is the size of the input stream. Adding an input element within the heap would take O log k for heap operations. And then m calls to add the total time complexity would be O of m log k. Basically, space complexity is O of n, so it's simple enough, right? So this particular solution should solve this particular problem. Let's run this script. Our case was solved. If we submit this, it's going to run this script through 20 cases, and all 20 cases passed. So that's how you solved the kth largest element in a stream problem in the blind 75 list of questions. With that, we're going to wrap this video up and see you in our next video. Thank you.